Hi, my name is Stuart Lynch, and this is the first of the real videos in the SwiftUI ToDo app series, where we're going to be building an app from scratch and then refactor it to use the combined framework. If you haven't watched the introduction, I suggest that you do so that you know what you're in for. If you enjoy this series, please give the videos a thumbs up and subscribe to my channel. Make sure you ring the bell to get notified when new videos are released. I encourage you to leave a comment below, and if you're so inclined, you can support my work by buying me a coffee. I'll leave a link in the notes below. This is the longest of the videos, so bear with me. Links to all the videos in the series are in the description below. We're going to be building this app from scratch, so please create a new SwiftUI project and make sure you choose the single app template. You can call it whatever you want, but I'm going to be calling mine My To-Dos, and I'll choose SwiftUI for both the interface and the lifecycle. This app's going to display a simple list of to-do items, and that to-do object will have a name and a status that will indicate whether or not it's been completed. Now, since we're going to be presenting our to-do items in a list, I'm going to create a model for all of our to-dos and call it to-do. So first, we'll create a new file called ToDo, and then inside that file, I'll create a struct called ToDo, and we'll make sure that it conforms to the identifiable and the quotable protocols. We want it to be identifiable because that will make it easier for us to identify each object and be able to display it in a list and modify or delete the items. And we want it to be quotable because what we will be doing in the next video will be encoding an array of these to-do items and saving them to our documents directory. And similarly, when we launch, we'll be reading from that file and decoding it. So because it's identifiable, we'll create a property called ID, and I'll make it a string and initialize it as a UUID string. Next, I'll create a property called name as a string, and then one called completed, that's Boolean, and I'll initialize it as false. Now, since we want to be able to have something to work with when we are designing our interface, let's create a static computed property called sample data that is an array of to-do, and let's create two sample to-dos. For the first one, I'll just use the name get groceries. And for the second one, we'll say make doctor appointment, but we're also going to set completed to true. I said that we're going to be creating this using the MVVM design pattern. So first I need to create a view model. So we'll create a file called data store. Inside that file, create a new class called data store and make sure that it conforms to the observable object protocol. And since it's an observable object, SwiftUI lets us observe properties that are wrapped with the @PublishedPropertyWrapper so that if they change, any view that's observing those changes will update. And we only have one right now, and that will be our array of to-dos, so we'll initialize that as an empty array. We're going to need to create, update, and delete to-dos, as well as save them to our documents directory, as well as load them. So within our view model, let's create functions that will be placeholders for those items. First, the function add to-do, and it will have one parameter that will be a to-do item that we'll use when we add to our array. Similarly, one for update to-do with the same parameter. For our function to delete, we'll use delete to-do, but we're going to be doing that from a list. So we'll pass the index set instead. And I want to create my function signature similar to one that I'll get when I call the delete method from a for each item in a list. This means @indexSet, where indexSet is of type indexSet. For the load to-dos function, we'll be reading from our documents folder, But for now, let's just update our to-dos array with our todo.sample data that we created earlier. And for the save to-dos function, let's just print out to the console that we've actually saved. Now the last thing we want to do is create an initializer for our view model that will load our to-dos when initialized. So upon initialization, we'll call the load to-dos function. Well, now that we have a data source, we can inject an instance of data source into the environment. And we'll do that in our file that is run when our app launches. And that's the one decorated with the @main. So when content view is presented, we'll inject an instance of the data source into the environment. And this will be an observable object then that will monitor published properties in our data store. Well, now it's time to design our app. And as I said in the introduction, I'm not going to spend any time with a fancy design. First, we'll need to access our data store, so we can do that by creating a variable for that using the environment object PropertyWrapper. Next, in our body, we'll create a navigation view, and inside that, we'll create a list. And within that list, we'll loop through all of our data sources to-dos using a for each loop. For each item in the list, I'm going to create a button, and I'll leave the action empty for now. But for the label, I'll display the todo.name in a text field. I'll set the font to Title 3, and then I'll set the text to be a strike through if the to-do is completed. Similarly, I can set the foreground color based on whether or not the to-do is completed. So, if it is, I'll set it to green. Otherwise, I'll just keep it as the standard label color. Next, I'm going to change the list style to inset group list style. Now, normally I'd use a navigation title and create a trailing navigation bar button item so that I can have an action to add new items. And the problem I find that it presents a lot of constraint noise in the debugger. So to avoid this, I'm going to create a toolbar. And inside that toolbar, I'll create two toolbar items. The first item will have a placement of .principal. And then inside that will be some text that is simply my to-dos. And I'll set the title to the large title font. And I'll set the foreground color to red. I told you this wasn't going to be pretty. For the second to-do item, I'll set a placement of navigation bar trailing. And this will be a button. I'll leave the action empty for now, but for the label, I'll create an image using the system name plus.circle.fill. Now to make this work in the preview, I have to inject an instance of our data source into the environment, just as we did for our myTodos app file. When we preview now, we see our sample data presented in our list with our navigation bar title and button. I'll repeat this one last time. I said it wouldn't be pretty, but I hope it'll be well coded. When we tap on the Add button, we want to present a form that will allow us to enter the name and specify whether or not the item is completed. This will be the same form that we use for updates. So again, because we're using the MVVM design pattern, let's create a view model for this form. First, we'll create the file and we'll call it ToDo Form View Model. Now, since it's a view model, we have to create a class that will conform to the observable object, so we'll create one with the same name and apply that conformance. Now this view model will have two published properties. The first one we'll call name, and I'm going to initialize it as an empty string, as it'll be when we create a new to-do. We'll also create a Boolean property called completed that will initialize as false. So when it's newly created, we'll have an empty string and a false completion. Now, if we're using this form to update an existing to-do, we'll need to know what that current to-do is. So let's create an initializer that will pass in a to-do that we'll call current to-do, and we'll assign the current to-do's name and completed properties to our classes property. Again, with update, we'll need to keep track of which one of our array items that we're passing in. So I'll create an ID property, but make it an optional string. Because if we're using this form to create a new one, we don't have an ID yet. So we can then complete our initializer by assigning the current to-do's ID to this one. Now we'll know if we're updating if our ID isn't nil. So let's create a computed property for convenience called updating that returns a Boolean based on whether or not the ID is nil or not. Furthermore, I want to ensure that people don't save to-dos without an actual name. So I'll create another computed property that's called isDisabled. And then I'll be able to set the disable attribute of our add or update button on the form we're about to create based on whether or not our name string is empty. Now we have all we need to update a to-do. But if we're trying to create a new to-do, we don't have to pass in any to-do object. So I'll create a second initializer that doesn't require us to pass in a to-do. And since every one of our properties has either a default value or is nil, Xcode won't complain. With our view model created now, we can create our new form view. So create a new SwiftUI file, and I'll call mine to-do form view. Now we'll need to access our data store so that we can update our array. So we'll access our environment object for the data store. We'll also need access to the to-do form view model, so I'll create an observed object variable called formVM that is of type to-do form view model. And then we'll inject an instance of this when we invoke our sheet. And finally, to be able to dismiss the sheet, we can access the environment's presentation mode and assign it to this variable. Now, in order to see a preview, we'll need to do two things. First, we can inject an instance of our data store into the preview. And then secondly, we'll need to pass in an instance of the to-do form view model. In the body, we'll create a navigation view that contains a form. The form is going to be a simple VStack with a leading alignment. And the form will contain two elements. First, we'll create a text field displaying a placeholder of the text to do, and we'll bind it to our view model's name property, the formVM.name. The second item will be a toggle using completed, and the toggle is on state is determined by our view model's completed property. And then we'll finish this form off with a navigation title called to do. Let me set the navigation bar title display mode to inline. Now we're not finished here yet. We still need buttons. But first, let's create some functions for this form. And I'm going to do that by creating an extension to the to-do form. I'm going to have two functions, one called update to do and another one called add to do. Now, in both of these cases, when I perform the action, I'll want to dismiss the modal sheet. So we can call the dismiss method on the wrap value of our presentation mode's environment variable. In the case of an update, we'll need to create a to-do with the information provided by our view model, and then execute our data sources update to-do function, passing back that to-do. Now, since it's an update, we must have used the initializer that passed in an existing ID, so our ID property will be non-optional. And we'll use that full initializer to create the to-do, and then, as I said, call the data sources update to-do function. So we'll use that full initializer to create the to-do item. And then, as I said, we'll call the data sources update to do function, passing this one back. For add to do, all we need to do is to create a to do, passing in the view model's name, because our initializer, which is the one that didn't require us to pass in anything, will assign a new ID, and it will set the completed value to false initially, which is what we want. And then we'll call the data sources add to do function, passing in that to do. Now, to call these functions, or to simply dismiss the sheet, I'll need to create two navigation bar items that will be buttons. So within our extension, let's create two computed variables that will return buttons. The first one will be called cancel button, and it will be some view, and what it returns is a button that is simply titled cancel, which just dismisses the sheet. For the second computed property, we'll create a new one called update save button, and it is also some view that returns a button. Now, the title of this button will depend on whether or not we are updating or saving. And we know that based on accessing our view model's computed updating property. So we'll set it to be either the word update or saved. Similarly, our action will change depending on that property. We want to call the update to do or the add to do function based on whether or not we are updating or adding something new. And then as an added touch, we can disable the add or update button of our form view to be disabled if the isDisabled property is true. Well, now we can create the navigation buttons for the leading and trailing, and we can assign the corresponding computed property for each. Oops, I'm not seeing that navigation bar. It's because I need to apply these modifiers to the form, not the navigation view. Common mistake. Well, now that we have our to-do form view model and the corresponding form, we need to have a way in which to present this modal. And I'm going to use a technique that uses an enum that conforms to both the identifiable and the view protocols. And I have a video on this, and I recommend that you give it a watch if you've never done this. It's a great way to manage your modal sheet presentations. So I'll create a new file called modal type. Inside that file, I'll create an enum, and I'll call it modal type. And I'll make sure that it conforms to both identifiable and view protocols. Now this enum will have two cases. The first being new, when we want to create a new to-do, and the second being update, but we'll need to know what is it updating, so it'll have an associated value of type to-do. Now, because it's identifiable, we'll need an ID property. So I'm just going to create a computed property for that returns a string based on the case. So I'll just switch and return a unique string for each case. And for that, I might as well just use the case name as a string. So that satisfied the identifiable requirement. But because it conforms to the view protocol, we'll need a body property as well. Well, that body is simply going to be our to-do form view. But I need to know which one to present. One that requires me passing in a current to-do or one that doesn't. So I'll switch again on the enum cases. Where the case is new, I'll just return the to-do form view. And it requires that we pass in an instance of the to-do form view model. And since it's new, we'll use that initializer where I don't need to provide a to-do. In the case of update, we have that associated value, which is a to-do. And thus, when we update, we can use that to-do and the second initializer of the to-do form view model to pass in that to-do. Well, we have all the pieces we need now. So how do we implement this modal sheet? Well, back in Content View, we can create a private state property called modal type. That's an optional modal type. And I'll set it equal to nil. Now, when we tap on an item in our list, it's a button. And what we want to do then is to present our to-do form view that will be an update. So we can set the modal type to .update using the to-do's associated value, which is the to-do that's in the list. For the toolbar items button action, we'll just assign a new case to the modal type. Well, now that the modal type is no longer nil, when one of those actions are executed, we can use this to create a sheet modifier on our navigation view using the initializer that requires a binding to an identifiable object, which is our modal type. Now this closure provides us with a modal type, which is a view that will be presented based on the modal type's case. And we can even shorten that like this. Now one last thing we have to do is update our functions to create and update and delete from our array. So back in the data store, in add to do, we are receiving a new to do, so we can just append it to the array of to-dos. In update to do, we get an existing to do, so let's find that out by comparing its index to one in our to-dos array. And for that, we'll use the array's first index method. Now, this is optional, so let's use a guard let to assign the unwrapped index to the index, else we'll return. And now once we have that index, we can update that one in the array with the to-do that we just received. For delete to-dos, we can simply use the array's remove at offsets function, passing in the index set. Now we have a function for deletion, but nowhere do we call this. So returning to Content View, we can apply the onDelete method for our for-each loop. And because the signature of our data store's remove function is the same as what we would need here, we can just use this method here to perform that data source delete to do method. Okay, time to test. First, when we launch the app, we see our 2 items from our sample data. Let's add a new one. Let's change one. Wait a minute, my Save button's disabled. I must have applied the wrong check on our to-do form view. Here it is. It should be disabled based on the isDisabled property, not the updating property. My bad. Let's test one more time then. I can add a new one and notice that the update button's disabled until I start to enter a name. I can edit one. And I can delete one. It's all working. But if I stop and start the app, nothing has persisted. We're back to square one with our sample data. In the next video, we'll be adding data persistence. But before I go, however, let's clean up our navigator a bit. Let's create 3 groups. And I'm going to call them Views, Models, and View Models. Inside Views, I'll move Content View and To-Do Form View. Inside Models, we can move To-Do and Modal Type. And inside View Models, we can move our To-Do Form View model and our data source. See you in the next video.